How are you guys doing today? Sleepy? Yeah. I know, it's one of those days. The sun was out for a little bit, but now it's pretty overcast and cold. But I hear a warm up is on its way, so gotta hang in there till the weekend, I guess. All right, so just taking a look at the calendar and what's on our plate for this week. So we did wrap up Unit 7 last week. 7.04 was the last lesson with our linear programming. Are there any major questions with 7.04 at all? I mean, you guys, from what I could tell, you guys did really well with it. The one thing that I did want to mention is with those unbounded regions. So I think two of the examples on the homework had unbounded regions where maybe it looks something like that. Of course, the lines kept going, but then you had the overlapping shaded region being in here. If you have an unbounded region, um, especially with the solution set being up here and extending indefinitely to that positive direction, you will not have a maximum amount, right? So you can't necessarily find a maximum amount because it's unbounded in that positive direction. However, there still might be a minimum amount. And what you have to do is you have to test these vertices here, these corner points, where your lines intersect to form that bounded region on the bottom half at least. And you're going to check for a minimum value. So even though there may be no maximum, there still will be a minimum. All right, and same thing if the shading was reversed, right? If you can picture it where maybe it goes down instead of up like that, and your shading was contained in the bottom half down here, the exact opposite is happening, right? You can have a maximum, but maybe you don't have a minimum value because it keeps continuing down in that negative direction. Not sure if we'll actually see that happening because most of the time we have kind of a low value like 0, right? So I don't know if we'll necessarily see a time where it's unbounded in that negative direction because we should have some type of constraint that's cutting us off at some point. So most of it's going to look like that yellow portion. So just wanted to throw that out there because I know a couple people were thrown off by that on if there would be a maximum value in the graph. So I wanted to address that as a whole. All right, were there any other questions regarding the linear programming at all? All right, if not, you do have a test coming up this week. You guys probably know the calendar a little bit better than I do. Is it scheduled for today, tomorrow? Might be for today, but I can't remember exactly. Yesterday, it was scheduled for yesterday. See, this is how bad my memory is. Yesterday, I went to bed and I'm like, oh, tomorrow's Wednesday. And my husband's like, tomorrow's Tuesday. And I'm like, what? So I lost a whole day in my head. So it's not uncommon here to think that I'm not sure when that test was, but it is scheduled for this week. All right, so not many people have completed that test, which is fine. You have a couple more days to get that in. Make sure you get it turned in before Sunday for sure so that you're not butting up against that deadline and get zeros put in. Yeah, that's fine. If you need more time to study or practice the concepts, that's totally fine. Today, obviously, we're looking at 8.01, and I actually plan on using Thursday as kind of a study day as well. So if you need to take a couple extra days, you have a little bit of wiggle room in there to complete everything necessary for this week. Yeah, so I'm not too worried if you haven't taken your test yet or if you're going to put that off for another day or so, that's fine. Don't forget you will need a calculator probably, more than likely, for your matrices. You can use your calculators to do your reduced row echelon form or your row echelon form, your inverse matrices, your identity matrices. You can use your calculators to help you out with that. Okay, even if you want to do it with multiplication, you can multiply two matrices or add two matrices together using your calculator. All right, so calculator is allowed on your test. And then if there's linear programming questions that you need to show, remember use GeoGebra for your linear programming questions so that you can copy that graph and put it into a Google Doc if need be. And then upload the Google Doc or put the Google Doc link into that test question area. Okay. Any questions regarding Unit 7? All right, then we're going to venture into Unit 8. I think you'll like Unit 8. Again, we're dealing with more kind of algebra type pieces here. We are starting off talking about conic sections. So a majority of this unit is talking about conic sections. So what exactly is a conic section? A conic section is a shape that is formed when you take two cones that are sitting on top of each other. So you can kind of see we have an upper cone and a lower cone. They call those napes, so you have an upper nape and a lower nape. And you're going to slice through that figure, and the section, the cross section that you're slicing through at is going to be the different type of conic sections that we look at in this unit. So the bottom level here is the three basic type of conic sections that we're not going to spend much time with. Just note that if you slice the napes right through the center, through that vertex, it's simply just a point. So right at the middle here, it's just a point for the cross section that you're cutting through at. So not too much interesting going on there. We're not going to spend any time looking at a point. We obviously know what that is. We are not going to spend time looking at a line either. So if you cut directly through on a perfect slant right here or in this opposite direction over here, your cross section will be just a line. We know the equation of a line and how to find it. We spent a lot of time in Algebra 1 looking at that. So we're not going to spend any time looking at that cross section of a line. We can also find intersecting lines if we just tilt the plane up a little bit and slice through the cones there on a little bit more of a diagonal, I guess you can call it, so a little bit steeper if we adjust the plane. If that's the case, then your cross section is just intersecting lines. And we've worked with intersecting lines in geometry and algebra. We are not going to spend our time looking at intersecting lines in this unit. What we are going to focus on are the three upper types of conic sections. So more importantly, if we were to slice through maybe the upper nape here, we can create an ellipse. And if the ellipse, we can also kind of group in a circle with that as well, because if I lift this end of the plane up, so the blue sheet, think of the blue sheet as like a piece of paper. If we hold that piece of paper completely level with the cone and we slice through that, the cross section then becomes a circle versus an ellipse. So circle and ellipse are going to be studied in the same lesson. So we'll talk a little bit more about how we can generate a circle versus an ellipse when we get there. Okay, but just note that those will be grouped together. We can also create a hyperbola. A hyperbola, remember, looks almost like two parabolas, but they're a little bit more slanted or swooshed, I guess you can call it, for the shape of the graph there. But generally, you'll have an upper part and a lower part for your hyperbolas. Okay. And then the one that we're going to start with, I kind of saved that one for last, is our parabola. And we have worked with parabolas in the past. especially in algebra when we talked about quadratic equations. That's when our parabolas come up. But there's actually more to it than what we've seen previously. So we're going to dive a little bit more in depth with these parabolas and the equations behind them. All right, so with this parabola, we're going to introduce a few new terms here today. You don't need to copy these down necessarily. I have another slide coming up that has a few more things added in. But here you can see that parabola, it's the U shape. Not only will our parabolas open up or down, so our parabola, and this is what we're used to, right? A parabola opening up or down. But now we're at the point where we can study parabolas that open to the right and parabolas that open to the left. Okay, so we're no longer just sticking to up or down. We can now look at left or right as well. All right, in every parabola, there is something called a vertex. Your vertex is the high point or the low point of your graph. So that does not change, right? So we'd have a vertex here, 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 and here. Through the vertex is what we call the axis of symmetry. And again, all parabolas are symmetric about that axis of symmetry. So if you want to graph, all you technically have to do is find a few points and then reflect those through the vertex. And then you can get that parabola quite quickly. Okay. Some new things now is the directrix. The directrix is on the outside of your parabola here. So you'll notice that that's going to make a 90-degree angle here with that axis of symmetry. Also, we have something called the focus. The focus is going to lie inside your vertex on the axis of symmetry there. So the focus will be inside it, and the focus and the directrix are equal distance away from the vertex. So those two pieces, those two red lines, are equal distance from the vertex. And again, it's actually going to be equal distance from any point on your parabola. So you'll also notice that these were equal distance right here. But if you look out further away, if I were to pick a point on my directrix and draw that up to the parabola, that distance there would still be the exact same as that point on the parabola to the focus. So no matter where you are on that parabola, the focus and the directrix will have equal distance from that point. Okay, this might be a decent one to start with. Actually, you know what? I probably wouldn't even copy, I definitely would not copy this down. I have a different chart that sums it up a lot better. But you'll just notice that some of the letters that they're using here are a little bit different than we're used to. Obviously, HK, we're used to H comma K representing our vertex. We've seen that in Algebra 2, Algebra 1, Geometry. H comma K, we're used to that being the vertex. Okay, so that has not changed. P though, P is representing that distance from the focus to your vertex or the directrix to your vertex. Right? So P cannot be 0. If it is, that means that your directrix is on your vertex, and we don't want that happening, and the focus would be on the vertex, and that can't happen. So that value for P cannot be 0 in between here. And there's some other rules here regarding P. If P is greater than 0, you know your parabola opens to the right, and if P is less than 0, it opens to the left. We actually have a different table that will help us with opening right or left as well. So, and versus up and down. Okay, so if you don't want to write this, that's okay. I probably would put this down. I'm not sure if I think it might be in our upcoming slide as well, but the width of the parabola at the focus is equal to 4 times p, and that's the absolute value of 4 times p. We'll be given a couple of equations that set us up by telling us what the width is. If they give us the width, we can then work backwards to find the equation for the parabola. So that's why I'm just noting that now, is because some of our examples will tell us what the width is, and we'll need to know what that's exactly representing so we can take an equation away from it. All right, here is what I would write down or copy down, and actually if you want, you could technically hold off a little bit longer without having to write this down, because there is another table that gives you information with your parabola where the vertex is at a generic h comma k. And if you want to hold off and only write down one table or include one table in your set of notes, I probably would hold off and wait to copy down where the vertex is h comma k, because you can apply all of the rules for the vertex being centered at the origin to that h comma k format as well. It's just that h would be 0 and k would be 0. So you would just substitute that in for all your information. So if you want to hold off a little bit longer still with copying that table down, you can do so. That way you only need one table for your parabolas versus a few of them. But this table, if we look at it, is going to help us to create the equations. It also tells us what direction it opens, if it opens up or down. And notice that if your x is squared, that is when your parabola is opening up or down. These are the parabolas that we're used to when we have the x squared. You can find the focus, the directrix, your axis of symmetry, your focal length, and your focal width. So if you have all this information, or at least one piece of information, you can probably create an equation for the parabola. Now, the parabola that we are exploring a little bit more is when it opens to the right or left, but just notice that things change a little bit here. And with your directrix, you do need to write the equation. The directrix should be a horizontal or vertical line, but we need to identify what type of line that exactly is. So I notice a lot that students tend to get a little bit lazy with the directrix, and they don't necessarily put x equals or y equals. But we do need to do that so that we can decipher what type of line the directrix is. All right, so let's actually put this all to use and create an equation. Or if we have the equation, can we pull information? That's what we're going to be looking at today, is going back and forth between the two. So this first example looks like they give us an equation and we have to pull the information from it. So it says find the focus, the directrix, and the focal width of the parabola whose equation is given right there. All right, first of all, what column are we looking at? Are we looking at the x squared or y squared column? So that's the first thing we need to identify. So which variable is your squared, the x or the y? We have differing views there. We need a tiebreaker. So Isaiah says x, Tommy says y. Which variable is squared in the equation? It is the x. Yeah, oh, and then Tommy changed. So we are focusing on this column of information right here as we pull things. Now, that is not the same. This equation that's in our box right here in the column is not the same as how it's written up here, because this looks like it has an x squared isolated. So let's rewrite this so it looks like this one. How do I rewrite this equation so that that x squared is isolated? Divide by a negative 1/3, and the same thing as dividing by a negative 1/3 is multiplying by a negative 3. Yeah, so multiply by a negative 3 on both sides, and you'll get that x squared isolated. Okay, so x squared equals negative 3 times y. Now it's in that format, we should be able to identify the pieces that we need, starting with the focus. All right, so the focus is dealing with that letter P. So we have to then figure out what P is. Any ideas how we can do that? I wouldn't substitute 0 for x. Instead, what I would do is take this 4 times p right here in our equation and set that equal to whatever the constant is in front of the y in the equation we have. So I would do 4p equals a negative 3. And that was kind of a bad 3, so I'm going to rewrite that. All right, then I'd work backwards to solve for p. So I would divide by 4 on both sides. And now we should be pretty good to go for pulling the rest of the information we need. So are there questions with how we found the p value in this equation up here? Okay, so the focus can be found at 0p, so the focus is at 0, negative 3/4. The directrix is next. And again, for the directrix, remember we're doing y equals negative p, so a positive 3/4 or 0.75 if you like your decimals. And then the focal width was the last piece of information that it wanted us to find. So the focal width is 4 times p, and that's the absolute value. So what is going to be our focal width this time around? 3. Good. Yep. All right, questions with how we gathered that information for that equation? All right, and you're going to see that I'm putting this table on every slide because it is just that useful. And I would expect you guys to do the same thing with your homework, is have this table or the table coming up right in front of you for each one so that you can constantly be looking back at it. All right, this time they're giving us information and we need to come up with the equation to represent the parabola. So it says find an equation in standard form for the parabola whose directrix is the line x equals 2 and whose focus is the point -2, 0. So the first thing I want us to do is identify what column we need to be looking at to create our equation. Should I be looking at column 1 right here or column 2 over here? And how did you know it was going to be the second column, Isaias? Yeah, your directrix is x equals. That was, I think, the main giveaway there, is the directrix line was x equals. Also, your focus was in that format of p0. So while we're at it, what is the value for p in this equation? So if we're looking at the focus, p is going to be -2. Good. That also fits the directrix as well, right? Because x equals -p. That means that p would still have to be -2. So since we have the value for p, the hard part is done. We're just going to come up to the equation and replace that value for p inside here and simplify. So it looks like we'll get a -8x for that one. Hey, not too bad. Questions with that example? So some of these go really fast, which is nice. All right, here's the table that you might want to add in your notes. And this is the one that has your vertex centered at h comma k. And this is the one that you can use even if it's centered at the origin 0, 0. It's just that h would be 0 and k would be 0. So this is the chart that I would, if I were you, I would copy down and I would be looking back at constantly for every problem. So this is the one that you want to have handy when you're going through your homework. Okay, I'll give you a few seconds here to start jotting that down if need be. It's also from the ebook, or not the ebook, the actual book. I had an ebook last year for my students. This year you guys have a hardcover textbook of it, but it's in there for you to look back at as well. And I'm also going to have it on all the upcoming slides for us to look at. So if you need to finish copying that down, I'll have it on every slide here on out. Notice that things just change ever so slightly with our formula. So instead of having that x squared, we just do x minus h. And instead of having the y, we do y minus k. Notice that they are using minus signs in the formula. So if I need to pull the vertex of h comma k, remember we're pulling the opposite values there. And they didn't list it, but it is in the title. The vertex can be found at h comma k. Okay, so again, here's that chart in case you were still copying it down. You can finish doing so here. Let's go ahead and take a look at an example using this now. It says find the standard form of the equation for the parabola with the vertex at 3, 4 and the focus at 5, 4. Okay, so now these are getting a little bit more challenging, but you can still pick out which column you should be working with if you pay attention to detail. So paying attention to detail, which column should I work with to create this equation? The first column or the second column? And again, how did you know it was that second column, Isaias? Because you are correct. Right, so if I'm looking at my vertex and my focus, I'm looking for what's staying constant between the two, because one of those values should be staying the same because they're on the same line. So is it the x value that's staying the same, or is it the y value that's staying the same between the vertex and the focus? In this case, it was that y value. So in my charts, I'm looking for the focus where the y value doesn't change. And that would be that second column, because you're not adding anything to the k value. You're changing that h instead. Good. So attention to detail is going to get you that right column to be working with. While we're at it, what is h equal? What does k equal? And we have to figure out what p equals as well. Once we have those three things, we can create our equation. So we'll start with h is 3 and k is 4. If it gives you the vertex, those should be the two easiest things to find, right? It's just h comma k, 3, 4. All right, p, Isaiah said, was 2. Now, how do you think we got 2 for our p value? What did we do? Yeah, we're going to go ahead and take a look at that focus of h plus p. And then we can set that equal to the direct or the vertex there, or 5 minus 3. You're finding the distance between the vertex and the focus, right? That's what I'm looking for. So p is that focal length, which is the distance between the vertex and the focus. It's exactly it, right? It's almost like playing a game. So the focal length there is 5 minus 3, which is going to give us our 2. Good. And the 5 and 3 came from the x values of the focus and the vertex. So in case you were questioning that, that's where those came from. All right, let's go ahead and create our equation now. So all it is, since I have those 3 values, is substitution. So we'll do y minus k squared equals 4 times p times x minus h. So I'm just going to simplify that 4 times 2 piece. And I am going to leave it just like this, okay, because it does say the standard form. So the standard form is without distributing and combining your like terms. Okay, any questions with that one? If only they stayed kind of that simple. We do get a little bit more challenging. It says prove that the graph of that equation there is a parabola, and then find its vertex, focus, and directrix. So if it's asking you to prove that it's a parabola, that means we've got to put it in the standard equation form. So we've got to write it like one of these two formats. All right, we should be able to identify which column we're going to be writing things as just based off of the equation we're given here now. Which column do I want to write my equation as? Column 1 or column 2? And how did we know it was the second column? You're correct, Tommy. Yeah, the y is what's squared. And over here, that's what's squared in our setup. Any idea how I can get this into the standard equation here? Any idea how we can get there? Once you hear it, you're going to be like, no. Or maybe you'll be like, yay. Kind of like factoring, it's called completing the square. Yeah, so essentially we're going to want to complete the square with the y's, which will get it into a factored form. Yeah, so the first thing we got to do is get the y's on one side and everything else on the other. So that's how we're going to start things off. So we're going to keep the y squared. I'm going to keep the plus 2y, but I'm going to move everything else to the other side. So I'm going to move the minus 6x over by adding it. And I'm also going to move the constant of 13 over by subtracting it. All right, so now to complete the square on the left-hand side, it helps if I put parentheses here. Remember, we take half of the middle term. So what's half of positive 2? 1, and we square it. So what is 1 squared? 1. Now to keep the equation balanced, whatever I'm added over here on the left-hand side, I must add to the right-hand side as well. So I'm going to go ahead and put a plus 1 over here. If I don't, the equation is now unbalanced and is not the same thing that we started off with. But if I add 1 to the other side as well, we're keeping that equation balanced. All right, we can then factor the left-hand side here. When we go to factor it, it always factors to y and then whatever half your middle term was. So we said half the middle term was a positive 1. All right, over here, I now have a 6x minus 12. Let's go ahead and take out the GCF because it looks like to be in standard equation there, we need to have an x kind of by itself in there. So what's the GCF we can pull out from the right-hand side? A 6. So if I take out a 6, we have an x minus 2 that's left. All right, so really that completing the squares process didn't take us that long at all. This is our equation in that standard form. Okay, so we proved that it was going to be a parabola because it fits that formula that we have boxed over on the right hand side there. Now that we have the equation, we can pull the information. So we need to find the vertex, the focus, and the directrix of this. So let's start with the vertex. What is the vertex? Remember, that's your h comma k. Be careful on where your h and your k are stored. What's the vertex? Good, Tommy. It's so easy to take that -1, 2, because we always are used to looking left to right in our problems, but the h is always housed with the x variable. So when I pull the vertex and I pull the h, I want to make sure I'm looking next to the x. So the opposite of -2 is +2, and the k value is always sitting next to the y. So that would be our -1 there. Good. All right, the focus is next. Before we can find the focus, it looks like we've got to find the value for P. All right, any ideas for how I can find the value of P in this scenario? Yeah, that's exactly what we're going to do. We're going to take that 4p in our equation and set it equal to whatever the value is that we have out there, which is our 6. So I would divide both sides by 4, and I probably would reduce that to a 3/2 as well. Okay, so now that you have the p, we can find that focus a little bit better. So the focus is at h plus p. So h was 2, and p was our 3/2. So when I add those together, what do we get for the x value? What's 2 plus 3/2? 3.5, yep, or 3.5, depending on how you want to look at that. Notice that the k value from the vertex didn't change because that's where your focus and the directrix is lying, right? The directrix, first of all, or the axis of symmetry, I should have said, not the directrix. The directrix is going to be where? What is our formula for the directrix? So we want to start with x equals, and if I come off to the side, we can find that by doing h minus p. So what is h minus p, or 2 minus 3/2? Yeah, a 1/2 or 0.5, right? Depending if you like your decimals or fractions. Good. Yay! Hey, that wasn't too bad, right? So that problem that we started off with looked pretty complex, but once we worked through it, it wasn't that bad. I think this type of problem is going to be one of the more challenging ones that you see as well. So if you're able to follow along with that, we're probably sitting pretty good right now. Any questions with that before we take a look at one more for today? All right, then we're just practicing from here on out. Actually, we've been practicing for a while. It says find the vertex, focus, directrix, and focal width of the parabola. So now lots of things we're adding in here. Before we start pulling information, we need to know what column we should be focusing on here. So should I focus on the first column or the second column to pull my information? Second all the way, because when you look to see which variable is squared, it's the y. So we are looking for that y squared variable, and that happens in column 2. All right, let's start with maybe the vertex, because I think if we can find the vertex and if we can find the value for P, then everything else will be smooth sailing. So let's start with H and K. What's our value for H and what's our value for K? H is -3 and K is +2. So I'm just going to come down here and pull that vertex and put it together. All right, what is our value for P? How can we find that? Yep, you're going to go ahead and take a look at what you have out in front of that X parentheses. So 4P equals 4. And you're going to work backwards to solve for P. And when you do, what do you get? P equals 1. Now that you have those 3 crucial pieces of information, you should be able to fill everything out using your chart. So we got the vertex already. Let's find the focus. Where is the focus going to be occurring? At what point? Yep, so off to the side, I did that H plus P comma K. -3 plus 1 is a -2 comma 2. The next thing we have to find is the directrix. Where is that occurring? And make sure we put that X or Y equals. So in this case, it'll be X equals H minus P. So that is our -4. But again, we need to have that X equals because sometimes it's a vertical line, sometimes it's a horizontal line. So we really need to decipher between the two by including the X or Y equals. The last piece is the focal width. What is going to be the focal width for this parabola? Yeah, focal width is found times the absolute value of 4 times P. 4 times 1 is just 4. Nicely done. Any questions with that? Okay, I think, well, we ran kind of out of time. I'm not sure if we can finish the last 2 I had planned, but since Thursday is kind of a study day, work day type thing, we'll come back here. I'll take your questions from 8.01, and if anything, we can take a look at these last 2 examples that I didn't get through here. I think, though, that you guys are going to be just fine as long as you have the charts to look back on. So again, I think it'll be really important to have those charts handy and in front of you every time you're looking at a question that's dealing with your parabolas. All right, any main questions for me before I let you go today? Okay, so we'll still plan on meeting Thursday morning, but it might be a shortened class, and you might have some time to work actually on that 8.01 lesson as well. But we will still meet just to go over announcements and maybe those last 2 examples I didn't get to today, but it may be a shortened class, so just a heads up. All right, that's all I got for you today. Good luck on your Unit 7 tests, and I'll see you guys all again Thursday morning. Bye, everyone.